Welcome back to another lecture on word problems or applications of rational functions. We want to do a word problem here. I will read the question because I know my handwriting is not that great. So if you cannot read, I will read it for you. Kelly traveled 15 kilometers to Wonderland from Tom's house at an unknown speed. She then returned to her home traveling 35 kilometers with a speed of 2 kilometers per hour more than her initial speed going to Wonderland. In total, she traveled for 8 hours. What was her initial speed? That's what the question says. Drawing a diagram is a useful thing always in problem solving. So Kelly was at Tom's house and then she traveled 15 kilometers to Wonderland from there. So this distance was 15 kilometers and we don't know what the speed was. So we may decide that speed is x. So we're going to say let x equals Kelly's initial speed in kilometers per hour. We don't know what the speed was. So we're going to call it x. So the speed was x here. So that's the speed equals x. And then the story of the problem says that she then returned to her own home, traveling 35 kilometers. So she was traveling 35 kilometers from Wonderland to her home. And it says with a speed of 2 kilometers more than her initial speed. So if her speed before, maybe she was driving at a speed of 60 kilometers per hour, but right now the speed is 2 kilometers per hour more than that. So it's going to be x plus 2. So that's the speed for the second half of the trip. And it says she traveled for 8 hours in total. And it says what was her initial speed? We need to find out. Of course, we don't know if she was riding a bicycle or she was driving a car, or maybe she was using a scooter. We don't know that. The question doesn't say that. Well, that's not that important. Okay, so in order to organize the given information in the problem, we are going to construct a chart, okay? And we are going to use a very, very famous formula from grade 9 science. And that is distance, okay? Distance equals speed times time. So D equals VT, where V stands for velocity. Okay, this comes from the definition of velocity that we used to say velocity is distance divided by time elapsed, basically. So we are going to use this formula, which is like a basic formula. So we're going to say what is the distance to Wonderland from Tom's house? And we know the answer is 15 kilometers. So we're going to write that down. And the distance from Wonderland to Kelly's house was 35 kilometers. So we are organizing the given information in a table, in a chart like this. It's not mandatory to do this, but after all, you want to make your process of problem solving easier and enjoyable. The rate or the speed is x initially. We decided it that way because the question is what was her initial speed. So whatever they're asking is going to be your unknown, basically. So you're going to write your let statement referring to what is asked in the question. So the speed from Wonderland to Kelly's house was a bit faster, so it's x plus 2. And the time, so we know that distance is speed times time, or speed is distance divided by time. But if you want to solve for time, that's going to be distance divided by speed, basically. All right. So if you want to find time from Wonderland, or actually from Tom's house to Wonderland, then you have to divide the distance traveled by the speed. And the distance was, of course, 15 kilometers, and the speed, we assumed it to be x. So 15 over x is that rational expression that represents the time, the traveling time from Tom's house to Wonderland. And then for the other part, from Wonderland to Kelly's house, the distance was 35 kilometers, but the speed was x plus 2. It was not x anymore, okay? Because the question says that the speed is 2 kilometers per hour more than the initial speed. So we have three quantities here. We have distance, time, and speed, and we filled in all the boxes in terms of our unknown. Now we need like an equation that links everything together. And that is stated in the last statement in the question. It says that the total traveling time was 8 hours. So 8 hours perhaps is a relatively long time. So maybe she was riding a bicycle, or maybe she was like using a scooter or something. Because if it was like driving, maybe it would be like faster. We'll see. We'll see. And this speed is like average speed. Okay. When it says what was her initial speed, is the average speed. Okay. All right. Um, so we're gonna say initial time was 15 over x, and the other time was 35 over x plus 2, and this is equal to 8. All right. So what did we do? We translated the English statements given in the story of the word problem into a mathematical equation. But this mathematical equation happens to be a rational equation. Now, only at this moment you understand what's the whole purpose of this, doing these applications of word problems. Earlier, when we learned how to solve rational equations, you were scratching your head. You said, "Oh, why do I need to know how to solve a rational equation? What's the point of that?" You learned what a rational equation was. You learned how to solve rational equations. So we talked about what, we talked about how, and now we are learning why we learned it. Okay, because we are solving real life problems actually with our knowledge of solving rational equations. So here, to solve this, we need to find the lowest common denominator between x and x plus 2, which is nothing but their product, obviously. So we're going to multiply top and bottom of the first rational expression by x plus 2. So we get 15 times x plus 2. The denominator is clear. And the other one, we're going to do the same thing. So 35 times x, and then the bottom x plus 2 times x. But then since we have a common denominator, I can combine the two fractions, and this is the next line. Simplifying 15x and 35x, you know distributive law, so this is just calculations. 15x and 35x is going to be 50x, and then we have 30 over x times x plus 2, which is equal to 8. Now it's time to do the cross multiplication. So 50x plus 30 equals 8x plus 2. And now we can do 8x squared plus 16x. And we can move everything to one side of the equation. So we end up with negative 50x plus 16x, which is negative 34x, and minus 30 equals 0. So we got a quadratic equation, end of the process. All of these numbers are divisible by 2, so I can divide both sides by 2 just to make the equation with smaller coefficients, which is relatively easier to solve. Can we factor this quadratic trinomial? If yes, we will. If not, we will use quadratic formula to solve the quadratic equation. No big deal, because we can always use quadratic formula. So we'll try to see if we can factor. So we get 4x and 4x. Two numbers whose product is 15, perhaps 3 and negative 5. So 4x squared, this is negative 20x, plus 3x is negative 17x, it works out. And then negative 5 times 3 is negative 15. And we factored it by the trial and error method. Now we're going to use the zero product property, setting each factor equal to 0. So either x is negative 3 over 4 or x equals 5. We understand that speed cannot be negative. So this negative 3 over 4 is a negative answer. So this is actually an inadmissible answer. We need to interpret our results. But x equals 5 is a positive answer. It is okay. And because it represents the initial speed, it is measured in kilometers per hour. So therefore, we figured out that Kelly's initial speed was 5 kilometers per hour. We need to write a final closing statement or a paraphrase to actually answer the question. The question says, what was her initial speed? You can't leave the question at this step. you have to answer it. And how do you answer it? By writing a final closing statement or some sort of paraphrase. So this example shows how we are using our knowledge of solving rational equations in solving real-life problems. And there is many different applications, different word problems, where when you translate the given information in the problem into a mathematical equation, you end up with a rational equation, and then you have to solve it. So I'll try to give you more examples in future, and thank you for your attention, and keep practicing as always.